This episode of The Energy Show is proudly sponsored by Sunlight and Power, the Bay Area's leading commercial and residential solar contractor. SLP has been designing and installing photovoltaic, battery backup, and solar thermal solutions since 1976. Help fight climate change. Go solar with Sunlight and Power today.
So, you want to save the world with clean energy? Make money doing it? Confused about the economic and technical realities of residential and commercial solar, batteries, heat pumps, EVs? Want the real-world scoop on new energy technologies, not manufacturer hype? Then tune in to the Weekly Energy Show, hosted by Barry Cinnamon. Insights from Barry's 40-plus years in the solar and energy industry will help you understand the future ways we'll generate and consume energy. And now, here's Barry.
Welcome to this week's Energy Show. On this week's show, we're talking about HVAC maintenance. Now, there's two big HVACs to worry about when you're talking about your heating and cooling system maintenance. Summer, when it gets really hot, and that's when the air conditioner breaks. It seems to always happen. Winter, when it gets cold and your furnace breaks. So that's when there's kind of peaks and panics of getting that HVAC system, that heating and cooling system working. Now, one good way to delay the replacement or the breakage of that expensive equipment is with something called preventive maintenance, just like your car. It's important to change the engine oil in your car, if you have an engine that is, and check the brake pads. Otherwise, if your engine breaks, your engine won't start, and if your brake pads are bad, you won't be able to stop. Your HVAC system is very, very similar, so it's important to take care of a few preventive maintenance tasks so that your heating system lasts as long as possible and operates at the highest efficiency. So for more about HVAC maintenance, I turn to Nate Adams. Nate goes by the House Whisperer moniker. He's a legend in the HVAC industry. His focus is on applying heating, ventilation, and air conditioning techniques the right way and taking care of insulation and air sealing issues that reduce efficiency. So he's not just one of these guys who's going to say, put in the best, most expensive, fastest, cheapest HVAC system. He's going to take more of a holistic approach. And bottom line, he really understands heating, cooling, humidity, and comfort issues, in addition to all the expense and operating cost issues. So welcome to the show, Nate.
Thanks for having me.
It's a pleasure. We've been talking on and off for the last almost a couple of years, and just glad to finally have you on the show. First, tell me a bit more about your House Whisperer career.
Well, it's funny. It started off with I needed a job. So I got into this by selling fiberglass insulation from a distributor to contractors that were putting in new houses, and then found myself out of a job because of the housing crash and became an insulation contractor. And the more I learned about that, the more I was frustrated that I couldn't solve problems that I thought I should be able to solve. So I was digging more and more into home performance. I met my now former partner, Ted Kidd, who taught me just a ton about how houses work forwards and backwards, basically all the physics that's involved. And we did some pretty cool projects where it was a balance of insulation and air sealing on one side and HVAC on the other. And I did a bunch of indoor air quality monitoring, a bunch of energy monitoring, a bunch of runtime monitoring, and really worked hard to figure out what worked and what didn't as far as making homes truly comfortable, healthy, and efficient. And came to a bunch of conclusions that a lot of people haven't because they haven't done that type of project. So it's led through a whole bunch of other things. I'd love to see the HVAC industry do more projects like this, and worked for 7 years creating the HVAC 2.0 program. It's meant to be a business model for HVAC contractors that actually helps them truly solve their client problems rather than band-aiding. But to be frank, I'm not totally sure that it's possible, and I had to back off of that a year ago or so. And I'm moving back to consumer education at this point, and then doing some consulting with contractors.
All right, so I was very impressed with the whole HVAC 2.0 program, and we're HVAC contractors also, and we're learning, and then we also have that trade-off between learning about doing the ideal perfect thing and then finding customers that are really willing to pay that. But most of what we're focusing on is really current heat pumps. It's a transition from furnaces and just plain old air conditioners to two-way bidirectional heat pumps. What's the relevance of what you learned with HVAC 2.0 to the transition to heat pumps throughout the U.S., throughout the world?
Honestly, it's pretty simple. When you watch run times, so like you watch how much a furnace runs, you will find out that it's between 2 and 4 times larger than it needs to be in most homes. And in California, it's going to be closer to 10x in a lot of cases. So what you find out is a furnace is actually the wrong piece of equipment for the vast majority of American homes. Heat pumps have lower outputs, so they're actually the correct piece of equipment for the vast majority of homes. And even the homes that do need a furnace, they only need that on the very coldest days of the year, and the heat pump can tackle the rest of the year.
When I switch to a heat pump in my house, I've noticed that the temperatures are very, very balanced. You don't get these spikes. You turn it on, you don't hear the air flowing, and you warm air, and the house heats up, and then it kind of cools down. It's just, you don't even kind of notice it's there. Plus, it's really, really quiet. So that makes sense. And, the irony, and you and I have talked about this at length, and you've got great Facebook posts about this and elsewhere, is basically a heat pump is identical to an air conditioner. It just has a reversing valve. So it's kind of stupid for us to continue to put in air conditioning compressors. So we can talk more about that, but kind of coming back to the basic topic here, what are some of the maintenance tasks that need to be done on systems? And, whether it's a ductless heat pump system or a ducted heat pump system.
Well, let's start with ductless. And everything basically comes back to keeping the equipment clean, because if it gets dirty, it doesn't flow the air that it should, and then the heat doesn't transfer. And that's fundamentally what we're looking at with both furnaces and air conditioners and heat pumps. We are transferring heat from one place to another, and you don't want the components to be dirty or the heat doesn't transfer as well. So ductless equipment, the big hang-up that it has is that it has very, very, very poor filtration. It's known as rock catchers. So I joke that it's good for stopping boulders and small children. And the issue is it lets a lot of dirt in the air through the filter. And in a ductless system, the coil comes before the fan. So by the time the air gets to the fan, it's cold when it's in cooling mode. And this means that if there's any dirt in the air and the coil happens to be wet, the fan happens to be wet, that dirt is going to get stuck on the fan. And it's going to clog up the fan over time. So, and it's called a blower wheel in the case of a ductless system, but that will get dirty and nasty and usually moldy. And that needs to be cleaned roughly every year. I mean, it depends on the system. It might need it every 6 months. It might need it every 3 years. And it depends on how much dust there is in the house. But if you don't do that, the performance falls, and also you're breathing some air that you probably don't want to breathe. And to do that well, they generally have to be either disassembled, or you can get a special kit that puts a little bib around the whole thing and it cleans it out from the inside. But it's a fairly significant time and material cost. So it's not super cheap to have done. And that's actually one of the reasons I'm not a giant fan of ductless systems, because they're fairly difficult to clean. And if you break something, the replacement parts are oftentimes hard enough to come by that the best solution is oftentimes to replace the unit again.
So I'm just kind of thinking about this. The ductless systems, you have sometimes a ceiling cassette that's flush mounted to the ceiling, or you might have a rectangular unit that's kind of stuck up in the corner of the room. So in both cases, you're going to have to get somebody who's trained on that equipment. I'm using the term trained with an I instead of an N-E. And trained on the equipment, and make sure that they know how to take it apart and carefully clean it with the components or not that facilitate that. Is it something that a homeowner can do? Because I'm used to replacing the filter in my furnace, but I never tried to clean a ductless head unit.
It's a doable DIY task, but it is a bit messy. I know I'd call it a 6 or a 7 out of 10 on a scale out of 10. So 1 being no big deal, 10 being full Bob Vila.
Yeah. Okay. All right, good. Well, on these ductless systems, anything else that needs to be cleaned? What about the condensate drains or the piping for that?
Yes, it's always good to double check that the drains are clear so that the condensate's still going outside. And it's the same thing with ducted systems as well. You want to make sure that the outdoor unit coil is not clogged with dirt or pollen or dust.
Okay, good. Now, what about ducted systems? What's the maintenance that we need to do on those?
So two different ways to look at this, whether it's well installed or not. So I'll start with the well installed one, where basically the only thing that you need to worry about is if the outdoor unit is clean. So like in Ohio where I'm from, we have a lot of dogwood trees. So if you are unfortunate enough to live underneath one of those, that could get sucked into your outdoor unit and it will clog up the coil on the outdoor unit. And again, everything about these systems comes down to free flow, either of air or of refrigerant. And for all these maintenance tasks, we're mainly just talking about airflow. So if the outdoor unit gets dirty and it clogs up the coil, that can cause all kinds of negative ramifications. But when it gets clogged, it raises the temperatures in the system, which can break a whole bunch of things over time.
So can you vacuum those coils or spray them with high pressure water or brush them out? What's the process?
It's usually you use a special cleaner. A Viper coil cleaner is a common brand name, and you spray that on the outside. You take if it's a traditional, vertical discharge outdoor unit, so a standard air conditioner, you take the top off and then you spray it out with a hose from the inside, and that blows all the dirt from the inside out. That's a DIY-able task, but it's also good, in my opinion, to make sure that you have a professional looking at your system every year or two anyway.
All right, good. Now, how would one go about changing the 4.5-ton vertical, Mitsubishi unit that I have at my house it's a rectangular unit?
That you'd probably need to pop the top off and spray it out from the inside.
Okay, so spray it with that Viper cleaner and then use a hose water from the inside out to blow that goop out the coils.
You got it.
Oh, all right. Well, when are you going to be in the Silicon Valley neighborhood to show me how to do this?
One of these days.
All right. And then, on a furnace, what about the condensate drain? How would I go about identifying when that needs to get cleaned out, the trap?
So, that'll switch us back to a poorly installed. Why don't I talk about why less maintenance is needed on a well-installed system?
Okay.
So a well-installed system to me is going to have a tight and large filter attached to it, preferably a media filter, which means it's going to be at least 2 inches thick. Usually they're 4 inches thick. And so they will have, say, 5 to 10 times as much media. So that's the actual, fabric in there that cleans the air. They'll have 10 times as much media versus a 1-inch filter. And so if that is a tight filter that doesn't allow a lot of air bypass through it, that won't allow dirt to get into the system. So now you don't have to worry about any condensate lines getting clogged. You don't have to worry about the indoor coil getting clogged because the filter's doing its job.
Now, it makes total sense because I have experience with that. And for 2 years, my mother-in-law was complaining that the furnace in her apartment, which is in the basement of our building, wasn't working. It would only go on for 5 minutes or 10 minutes, and then it would shut off. And we finally got somebody out who knew what they were doing and basically said, the condensate drain was clogged, and then it was just finding that there was a problem, and it was short cycling. So they fixed that, and then everybody was happy. Any other things, either for ductless or ducted systems, that people should be aware of that would come as part of a regular maintenance?
Yes. So most systems don't have a good filter on them. So they're allowing garbage into them. And that is where there's a couple of key things. One is you want to change the filter. If you've got a basic filter, that probably should be changed about every month.
Wow.
If you have a good media filter, they may need to be changed as often as every 3 months, but it may be as little as once per year. And basically you can watch the filter visually to see when it looks really dirty, change it.
Okay. Is it possible to wash those filters, or you just got to change them?
You just got to change them. And also, if you've had a big wildfire, change the filter.
Yeah, okay. All right, good, good. All right, well, let's say we've done all that. Maintenance on the system is good. It's being done every year or so. With that kind of proper maintenance, how long would a natural gas furnace or an old-fashioned air conditioner last?
Well, if the maintenance, well, if it has the good filtration in particular, and the pressure inside the ductwork is reasonable, and it's the right piece of equipment. So there's a couple of ifs there, but with those in place, systems should last 15 to 20 years.
Okay, all right, good. All right, well, now let's go into the diagnosis side of things. What happens, how can you tell when you have a clogged filter?
Well, there's a few different things. I mean, you can pull it out and look if it's dirty, but a common thing that you'll find in 1-inch filters in particular, because they're typically too small, you'll find them actually bend so that they're getting sucked into the unit. And sometimes they will actually come loose and get sucked into the system, which can cause all kinds of havoc. That'll mess up the fan motor. It can clog all sorts of things. And then you're allowing unfiltered air through your system, which is likely going to hurt its lifespan. And unfortunately, I'm hearing of a lot of systems now are only lasting between 8 and 12 years. And oftentimes they are being maintenance nightmares in the meantime before they get there. And part of this is bad installs. Part of it's not good enough filtration. Part of it's oversizing. There's a lot of different pieces.
All right, good. All right, so how can you tell when you have clogged coils?
Visual is probably one of the better ways to do that. So you'll need to take a panel off the front of the system and look to see if the coil looks dirty, if it looks clogged. But it can be partially clogged and it's not super obvious. So the other way to do it, and really the better way to do it, is what's called static pressure testing, or I call it duct pressure testing, where you measure the pressure in the system before and after the system and before and after the filter. But for that to truly be useful information, it's better to know what the system was when it was new, because a clogged coil may or may not be super obvious.
All right. Okay.
Without before and after.
All right. And then if it's an outdoor unit, you can just, see if it's clogged with dogwood leaves and debris. So
yes,
that's
yeah.
pretty easy. Okay. Now, ductwork. How can you tell if you have leaky ductwork?
Well, you can run a duct blaster, but duct blasters, a tester, are doing that sort of thing. But honestly, most ductwork is leaky. And the leaks that you really want to pay attention to are the ones that go outside of the house. So if you have ductwork that goes into your attic or your crawl space or the garage, those are the leaks that you want to pay more attention to. And oftentimes you can just see them visually if there's cracks, or you can feel for the leaks.
All right. Or you just hire somebody to open up the crawl space access and crawl around there and turn the system on and see if they feel a breeze.
Right.
Yeah. Okay. Condensate drain lines and condensate pans. How can you tell if that's clogged? Is it something you can see visually?
Oftentimes those need to get snaked out or blown out. So the challenge with all of these things is there's clogged and there's partially clogged. And the clogged is easy to figure out. So if you have a clogged condensate drain, particularly if you have a system that's in an attic, that will oftentimes overflow the drain pan, and then it's going to get your ceiling wet at a minimum and make the ceiling drop at a maximum.
Right.
So that's one way to find it out. And the other thing is that is something that should be done at a regular maintenance. If you don't have that good filtration, you should blow out the condensate line.
All right, good. All right, well, we're learning a lot, and there's a lot of opportunity here to do this preventive maintenance so that these systems last longer. So let's get down to costs. How much, just ballpark, national average or a range, how much would kind of this annual maintenance cost, and how much is that going to save in terms of the longevity of the systems?
So good questions. Typically, a basic maintenance is somewhere between $200 and $400 is what I see. Don't kill me if I'm wrong, because California prices do tend to be on the higher side of things. But those can help buy you some extra time. And particularly the older systems, say through 2010 or so, they were a bit stouter than the systems since then. So if you're nice to them, you may be able to limp them along for another 5 years or so.
All right, right. And then that's just a kind of a trade-off. Are you going to spend some money every year to make sure that everything's running properly, and that's going to help the system last maybe, 5 years or so longer? You'd save a lot of money that way.
Correct.
All right. Okay, so you read the news and you see that heat pumps are the way to go or very popular, and then you kind of dig in a little bit more and you see actually there's more heat pumps being sold in the U.S. than gas furnaces. How is that trend evolving, and why are we still installing so many non-heat pump systems?
So I think we're seeing at least a handful more dual fuel systems across the country. But the one thing that I really don't like about that particular stat is that while, yes, the furnaces and heat pumps are both roughly in the 4 million units per year range, we're selling closer to 6 million one-way air conditioners per year. So that's the number that we really need to look at on the electrification side of things. And while we're seeing a gradual shift from one-way air conditioners to two-way heat pumps, we're looking at, say, a 3 to 6% per year change. So we're still quite a ways out from the complete conversion happening. And honestly, I think it's going to tail off because where I'm from in the Midwest, furnaces and air conditioners are just the standard. Wow. And because most systems are replaced in an emergency situation when either the furnace or the air conditioner breaks, people are going to minimize that expense. And an air conditioner is a few $100s less expensive wholesale than a heat pump. So the air conditioner is going to be what gets sold. So until that shifts, I don't see the complete shift happening.
But that's not a lot of money. Does that $200 or $300 difference really including installing a complete new heat pump system, heating and cooling?
Well, no, not quite. That's what you see is if most heat pumps and air conditioners, say most air conditioners have an equivalent heat pump model, and the cost difference between them is usually somewhere between $300 and $800 wholesale.
Okay.
And then it's marginally more work to put in, not much, like half an hour. And then you need to bump from a really basic thermostat to a mid-level thermostat, which is another, say, $50 or $100. So generally the installed cost differences that I see between a heat pump and an air conditioner are about $1,000 to $2,000.
I mean, in California, that's a no-brainer. Right? Even if it's twice as much, $4,000 or $5,000, it's time to do that. Whether your furnace dies or whether your air conditioner dies, do it now because you're going to save money if in the California climate, and you're going to save money pretty much everywhere if you have solar. So we're talking about the equipment costs. Let's change a little bit, change gears, and let's talk about the operating cost savings from heat pumps compared to electricity and gas standard systems. And I kind of crunched some of these numbers because I did this on my house about 5 years ago, and my amortized cost of electricity is about 10 cents a kilowatt hour, and that's on the high side. And that works out to $3.11 of therms equivalent, making some assumptions about efficiency, et cetera. And if I look at the cost of natural gas on the same basis, if I look at that natural gas cost in terms of the efficiency I get, it's 62 cents on electricity. So with a heat pump, I'm basically heating at 62 cents a therm compared to over $3 a therm on my old system. And right now, the current PG&E gas rate is $2.50 a therm. So I'm just coming out way, way ahead. It's like 4 times cheaper to run my heat pump with solar generated electricity than it is to buy natural gas from my utility. How do those numbers, this is California, we've got a good climate, electricity is through the roof, natural gas is through the roof. How does that compare to other parts around the country?
So around the country, I just say it's comparable because it changes from year to year depending on what the gas rates are doing and the electric rates are doing. But in general, you're talking plus or minus 1 or 2 dinners a year, or plus or minus $100 or $200 a year in operating costs between a heat pump and a furnace. That's what almost every house that I've looked at comes in that range. Now, there's going to be outliers depending on what market you're in. Like Michigan has cheap gas but expensive electricity, so they have a large spark gap. So the math in Michigan sucks. But like the math in Ohio or West Virginia or Indiana is pretty reasonable. And again, it's going to vary slightly from year to year. But the key thing is it's comparable. You're going to be within a couple $100 a year, one way or the other.
All right. And it also depends on where you go out to dinner. I mean, you could be like our governor who had a nice dinner at the French Laundry, or you could be like my wife and I, where every week we go to Chipotle when we don't feel like cooking.
Yep, exactly. Although, man, McDonald's costs $40 anymore.
Yes.
So
you can't get away with, less than 30. Well, Chipotle, we're down around $20, but that doesn't include the drinks and anything else. And we buy we
just
make our own
did Chipotle
chips.
this week. So that's what my wife wanted.
What's your favorite dish there? I know we're digressing quite a bit, but what do you get at Chipotle?
I keep coming back to their chicken. They've got the best chicken.
Yeah.
In a burrito.
We get the chicken burrito bowl. That way it's easier for us to share. So, all right.
There you go.
All right. So we talked about upfront equipment costs. We talk about operating costs. One of the other big benefits, and I mentioned this early on, is that the comfort differences between a heat pump and an old-fashioned gas furnace and air conditioning is tremendous. But why is that? Why is a heat pump so much more comfortable?
It's all about the even distribution of heat. The easiest way to think of it is, imagine you have 10 gallons of hot water to get clean with. And you have the choice of either having one giant 10-gallon bucket dumped over your head all at once, or taking a 5-minute shower. So it's the same amount of energy, the same amount of hot water, either way. But which one would you prefer?
Yeah, it's just regulated better. It's just operating in a steady state. And that's one of the reasons why it's more efficient.
Yeah, nice, easy stream. So furnaces, like I said, are typically anywhere between 2 and 10 times larger than they need to be. Heat pumps are actually oftentimes still too big too, so it's important where they can turn down. But a good heat pump can turn down to 25% of its full capacity. So say it's a 3-ton heat pump, which is 36,000 BTUs. It'll turn down to 9,000 BTUs, which is 3/4 of a ton. It's not very much. The window AC is 5,000 BTUs. So if you can get that nice even stream of heat or cool that's just constantly running through your house at a low volume, and you're mixing the air and you're stirring the house and all the building materials in your couch and the ceiling and the floors, and everything is getting to be very even in temperature, the comfort that comes from that is frankly astonishing.
Yeah, and we experienced that. And then the other thing we noticed was that the heat pump system just runs really quietly. Whether you're outside at the compressor unit, when it starts up, I measured it's only drawing an amp. You can barely hear the fan. But when it's heating on a really cold night, the thing's cranking, and the air coming out of the ductwork is nice and warm. So really nice the way it regulates itself. It's a variable speed motor and a whole variable speed system instead of the older systems, which basically were on off. And and the analogy for your car is heat pump's got a gas pedal or an adjustment pedal, whereas imagine what would happen in your car if you basically just turned it on and you were going full speed at 200 horsepower, and then you turned it off and you cycled it. Huge difference in efficiency. Just kind of, setting the stage back, my first experiences with heat pumps was back in the early 80s when I was installing the first ground-coupled heat pumps. We were drilling these deep wells in the ground and hitting water and putting heat exchangers down there. But even then, and this was in Boston, the cold weather performance of the heat pumps really wasn't there. You really needed to use a lot of emergency electricity heat. How do heat pumps work right now in cold climates?
So 2 different types of technologies. The older school heat pumps, which is still a good chunk of the market, they just do okay at cold temperatures. And that's where they're oftentimes better suited to be in a hybrid setup where it's a heat pump paired with a furnace, and the furnace takes over at the colder temperatures. But when you talk about the cold climate capable, or really it's inverter-based heat pumps, an inverter, I should pause just briefly. Well, this from solar. So you're getting DC power and you need to convert it to AC. So in inverters and heat pumps take AC power, they convert it back to DC, and then they convert it again back to AC, and they can vary how fast the compressor is spinning, how fast the motor is spinning. And with that capability mixed with a few other things, we can make heat pumps that work really well down below 0 Fahrenheit.
Are they using the same refrigerant for those cold temperatures, or some kind of special refrigerant?
It's the same refrigerant. It's just a bunch of extra magic that goes into it. And it really is wild how well they work. And I mean, they do lose capacity as it gets very cold. Like there's no way to defeat physics on that. There's less heat in the air to remove, but they can hold their capacity. There's a number of models now that can hold it down to 5 degrees or 0 degrees, sometimes minus 10. And that lets you use heat pumps in climates that 10 or 20 years ago would be unthinkable.
All right, that's a huge progress. All right, well, most of what we're talking about and most of the systems, actually all the systems we're installing now are air-to-air heat pumps where you have a heat exchanger and a unit outside that takes the heat out of the air and then it subtracts or adds the heat into the air in the house. But there's also air-to-water heat pumps for hydronic heating systems where you may have radiators. How are those systems doing in the market and how are they from a cost savings perspective?
So the challenge with those is that they're just not common in the United States yet. They're relatively common in the EU, and they're getting much more common right now because of the Russian gas situation over the last couple of years. Europe is working very quickly to get off natural gas. But in the United States, the systems, there's not a lot of them, and they're pretty expensive, and they're relatively sensitive to install quality. So it's still basically an early adopter product, but it's something that I'm keeping an eye on. And also in the future, I think that's probably where we're going to go because the next round of refrigerants that we'll be changing to are likely to be propane and carbon dioxide, which both have challenges. Propane is pretty flammable, and carbon dioxide to run as a refrigerant needs to be running at very high pressures in the 1500 psi range or so, which is 100 bar. And so you want to keep those refrigerants outside, just in the outdoor unit. And then you could use water or coolants to run the actual heating and cooling inside. So I think we'll move to that over the next decade. But as for now, it's much more of an early adopter product.
And how would they do cooling? You'd basically just push cool refrigerant or cool antifreeze throughout coils?
Yep, exactly. I mean, that's just how your car works. The car has the hot coolant going through it, and then you blow cooler air through that to cool off the coolant.
All right, good. Okay, well, heat pumps are quickly established technology. It's not brand new, but it's still kind of new to a lot of people. Would you recommend getting one for your mother?
I have. I was ignored, but I have.
Does she still talk to you?
Yes. Yeah, I think she thinks I'm a little bit crazy, but that's okay.
Yeah, it's okay. We're all kind of crazy. So, all right. Well, what kind of system does she have?
Well, so she lives with her second husband now, and she has a furnace and an air conditioner, and neither is one that I was happy with. But when the actual thing happened, I wasn't consulted.
All right. Okay, good. All right. Well, how can people get in touch with you? What's your website? And, are you on Facebook anywhere?
So I run the Electrify Everything group on Facebook, so that can be a good place to find me. You also find me on Twitter. My handle's EnergySmartWV, short for West Virginia, where I live. And then my website, which could be pretty useful, is natethehousewhisperer.com. And much of my book, The Home Comfort Book, is available there for free download. It costs an email, but that's all. And then if you click on the contact link there, you can also buy an hour with me if that's something that's helpful.
All right. That's super. Well, that's all the time we have on this week's Energy Show. Nate, thank you for joining me on the show. And thanks to all of our listeners for tuning in. If you missed any of today's show, you can go to the Energy Show website at energyshow.biz and listen to the podcasts.
This episode of The Energy Show was proudly sponsored by Sunlight and Power, the Bay Area's leading commercial and residential solar contractor. SLP has been designing and installing photovoltaic, battery backup, and solar thermal solutions since 1976. Help fight climate change. Go solar with Sunlight and Power today.